Hey class, we are going to dive right into chapter 1, which is called Introduction to Statistics, the same title as the class, so that's interesting, but mostly this section is laying the foundation and groundwork for the entire class, basically what goes into a statistical study, all the nuts and bolts and that sort of thing. So what I typically do, since this is the first video, just so you know, I go through the notes that you have available to you. So if you have the notes in front of you and you want to follow along and take notes, your own notes as we go through, that's awesome. Also, after I do a video, I post the completed notes, what I write down as I go through the videos. So let's get it going. So this first page, which is actually page 7, gives you some definitions. So the first definitions is statistics. So, think about that as the science of collecting and organizing and analyzing and then interpreting data. I mean, all the chapters that we go through for the entire class probably are going to be one of those 4 things, and the details that go into it. And then you can read some of this on your own. So a study is, pretty much what you would expect it to be. Data consists of information coming from observations, counts, measurements, responses. So any kind of data, lots of different kinds of data we'll be looking at. Some of the questions that you're going to do in your homework probably are going to start here with population and sample. So it's really important to distinguish between those 2 things. So think about population as all outcomes that are of interest, right? Whereas a sample is just a subset or a part of a population, right? So subset. So a sample is just a subset of a population. Now, a population could be the entire country, could be people in the state, it could just be, the people in your class, right? It just depends on who or what is of interest, right? That's the key there. And then we have the terms parameter and statistic that go along with those. Those are numerical descriptions. So parameter always goes with population, and statistic goes with a sample. Right? So nice thing is that parameter and population start with P, statistic and sample start with S, so it's easy to remember in that way. And then the 2 major branches of statistics, the first part of the class will be doing descriptive. That's basically like graphs and organization and all the numbers that are involved. And then the inferential is then making conclusions, right? And drawing conclusions based on a sample about a population. Okay, so let's look at some examples. Here's a case study. In this study, we have adults between the ages of 40 and 69. So it looks like that's a key piece of information there. Right? This is about sleep duration. After 9 years, approximately 40,000 participants were selected to undergo brain MRI. So it looks like they're the subjects in this study, right? And then there's an evaluation that took place, right? So let's try to come up with some answers to these questions. Identify the sample in the study, right? So the sample in this case is who was involved in the study, and that's those 40,000 participants, right? So sample in the study, we could just write the 40,000 participants. And you could even get more detailed there, like what was the data that was collected. We could say, we don't really have it here, so we don't really know, but what was collected, probably something about sleep hours and how many hours they slept compared to what they found in the brain MRIs, etc. But in general, the sample is just those subjects. Now, the population in the study is who do those represent, right? Who do those 40,000 participants represent, right? Well, specifically, this is done for adults between ages of 40 and 69. So a good word to use for population is the word all, right? So all adults ages 40 to 69. Sorry, I kind of write sloppy when I'm doing these videos. I clean it up after and post it so it looks nicer. Okay, so notice all of these 40,000 participants here, right? These 40,000 are adults ages 40 to 69, but there's just 40,000 of them, whereas the population is all adults ages 40 to 69, not just those 40,000, but all of them, right? So these 40,000 are representing the population as a whole. Okay, another one. How about in a national survey of 1,060 parents of teenagers, it was found that 63.6% of parents have checked their teens' social media profile. So what's the sample, right? So we can see that the sample we have right there, right? That those 1,060 parents, those are the ones that were involved in the study, right? So the 1,060 parents of teenagers or just in the study. Okay. Now the population is always a larger group, right? What do those 1,060 parents represent? So that's when we use the word all. All parents. And I wouldn't want to stop there because we're not talking about all parents. Specifically, we're talking about all parents of teenagers. That's important. Right? Like these, the sample is not representing parents of toddlers, for example. Right? Okay, and then describe the sample data set. What was found, right here we have that 63% of parents have checked their teens' media profile. That's the sample data set that was found, right? So I could just, if this is the question, just describe, well, what was the result, right? Of parents have checked. And a lot of times you're just copying something that was in the original question. Okay, so that's pretty straightforward, I think. You know, you get used to sample versus population. We'll be using those words all semester. Okay, how about statistic versus parameter? That's what this one has to do with. So National Football League, concussions were up 3% from the previous year. The league said there were 219 documented concussions in 2023. Up from 213. Okay, so in this study, does the 3% represent a statistic or a parameter? So when you're looking between statistic and parameter, you have to decide, is this referring to a population or a sample? And notice in this problem, they're talking about all of the players in that 2023 season, right? It's not just a small sample of players, but we're talking about all players. So since it's all the players that are being included, this would have to be a population, and so it's a parameter, right? So which one, so we have two parameters here, but which one goes with the correct type, and that's population, so I would go with this one right here, right? It's a parameter since the value is a numerical measurement describing the characteristic of a population, okay? Here's another example. Okay, if you want to try this one on your own, hit pause and try it, and then you can see if you got the right answer. But what is the sample here? Okay, so who do we have? All right, looks like we're studying young adults ages 18 to 39, right? And here's the word sample right there, right? Okay. And they did the sample of ages 18 to 59 so that they can do a comparison, right? Okay, and then finally, analyzing surveys, approximately 3 million, right? So identifying the sample, there it is, right? The 3 million surveyed. Oh, what happened there? Okay. And then the population, right? Well, what do those 3 million represent? All adults ages 18 to 59. Okay. And what inferences were drawn in the study? Usually that comes at the end, right? What did the researchers find, right? So researchers found right there, younger adults' self-reported anxiety and depression were more elevated than older adults. So then really you can just copy that, right? You just basically you're finding it in the question, right? So I could just copy that down. Younger adult, whoa, wrong pen. Younger adults, specifically those ages, 18 to 39? Okay. You can fast forward through this if you don't want to watch me write my chicken scratch. Okay, there we go. All right, let's look at one more. What do we got? Yeah, that's the last one for this section. Great. Okay. Marriage is heartwarming. Scientists evaluated. Okay, so I can start looking for the sample right away. There it is, right? So I can just identify the sample. Notice sample always has a number involved. 3,000 men in the study. Sample always has to do with the people that were actually involved in the study. Population is who they represent. All, right, men in the U.S. Sample data set, what was found? Married men, 46% lower rate of cardiovascular disease, right? So, married men, 40% lower rate of heart disease, something like that. Right. Is that 46% a statistic or a parameter? Well, it's based off of that sample, so it's got to be a statistic. Right. And what inferences were drawn in the study? Right. Well, pretty much same as the sample data set, right? There's a correlation between being married and having a lower rate of heart disease, right? So there is a link between being married and rate of heart disease, or something like that. Right? Notice what we're not saying is that being married causes lower rate of heart disease. Right? So if we wanted to cause and effect relationship, we'd have to do a lot more research. But we definitely can say that there's a link. Right? And we'll get more into that when we get into chapter 9 with correlation and causation and that sort of thing. Okay, so that's the end of section 1.1. Give it a try in your homework, and the next video will tackle the next section 1.3. All right, thanks for making it all the way through the video. Talk to you later. Bye.